Hello everyone, welcome back to my channel. So today we want to solve this question right here. As we proceed, if you are new to our channel, just do what to give this video a thumb up and of course subscribe to our channel so that whenever we release new content you will actually get to know about it. Okay, so how are we going to be proceeding to solve this? Okay, so the first thing I want to do is I'm going to bring this to the left hand side, and if I do that, I'm going to be having that my question will change to x raised to power x plus 1 and then minus x is equal to 0. Okay, so this is what I have. So the next thing I want to do is I want to split this right here. You remember that in indices, if you have a raised to power, let's say a raised to power m plus n, you can actually write this as a raised to power m times a raised to power n. So this is what I am gonna use to actually expand this right here. Okay, so if I do that, I'm gonna be having that this I can write it as x raised to power x right here, and then times x raised to power 1. Okay, so minus this x is equal to 0. Now, having written this, you can see that x raised to power 1. Of course, this x here is also x raised to power. So what I'm going to do is I'm going to factorize this x raised to power 1 right here. Okay, and if I do that, what I'm going to be having is x, okay, raised to power 1 into, okay, I'll have x raised to power x right here, and then minus, if I factorize it here, 1 will remain and it is equal to 0. Okay, so what am I going to do again? Okay, so if you remember the zero product rule, which basically say that if you have a times b and it is equal to 0, that this actually implies that it is either a is equal to 0 or b is equal to 0. So I'm going to be applying that right here. Okay, now if I clean this, I'm going to have that from here that x is actually equal to 0, or x raised to power x minus 1 is equal to 0. So we're going to be taking these cases right here. Okay, so clearly from here you can see that my x is equal to 0, and if I want to check whether this is correct, I can just go over to the question right here. This is x, the question x plus 1 equal to x right here. So if I want to substitute x for 0, you can see that if I put 0 raised to power 0 plus 1 right here, and I'm checking whether it is equal to 0 for x, and if I do that, I will have that this is 0 raised to power 1. Okay, 0 raised to power 1 is equal to 0, and of course clearly 0 raised to power any positive exponent is actually equal to 0, so which means that x equal to 0 actually is correct. Okay, so the next thing we want to check is actually the second case right here, which basically say that x raised to power x minus 1 is equal to 0. Okay, now how do we solve this? You can see we can actually take this minus 1 to the other side, and if we do that, we have that x raised to power x here is equal to 1. Okay, so what we just do is we just find a way to write this in form of this, and of course if we do that, we can actually write this 1 here as 1 raised to power 1, and you can see here that 1 raised to power 1 is also 1, and clearly we can actually equate them right here, and we have that this actually implies that our x is equal to 1. So our job now is actually to check whether x equal to 1 satisfies this problem. So if you want to check right here, the question actually says x raised to power x plus 1 is equal to x. Okay, so if our x is equal to 1, so let's check. So we have 1 raised to power 1 plus 1 is equal to 1, and here you have that 1 raised to power 2 is equal to 1. Of course 1 raised to power any number still gives you 1, so this is also correct. And so we are seeing that the two solutions for this equation right here is that our x is equal to 0 or our x right here is equal to 1. And of course, we've checked that the two of them actually satisfy this equation. So thank you so much, and of course you can do well to subscribe to our channel for more updates, and I'm going to see you guys in my next video. Bye.